Hello everyone, welcome back to my channel, and as you all know we are doing a problem session and we have already completed 5 problems, and right now we are going to do problem number 6. Okay, so in our previous problems we have covered various topics like aromaticity, like resonating structures, their stability order, etc. Currently we are operating on a new topic, carbocation and carbanion. So let us first see our problem number 6 and we'll analyze afterwards. So as you all can see on your screen, we have a compound. On the right hand side you can see I have given you a compound. Student, this compound has 4 chlorine atoms. I have numbered them A, B, C and D. Now what is the chemistry in this problem? I have reacted this compound with Ag+. What is the role of Ag+? Ag+ has a strong love for, affinity for Cl-. So Ag+ is going to pull away any one of the 4 Cl atoms which are attached to 4 different carbons in this compound. Now you should understand one thing. Ag+ is ready to pull away one of the Cl as Cl-. Now which Cl it would be, it depends on how loosely it is attached with carbon. For an example, there is one Cl which is attached firmly, strongly, and there is another Cl which is attached loosely. So which one Ag+ is going to find easier to remove? Obviously the one which is held loosely, first of all. Second of all, you should understand, as you give away the Cl-, you should understand, as you give away the Cl- to Ag+, the carbon from where the Cl was attached earlier, before you have taken it away, after you remove the Cl-, this carbon will acquire a positive charge. Why? Because Cl will take away both the electrons involved in the bonding along with it. So carbon will be left with a positive charge. So the matter is, Ag+ is going to pull away the Cl which is easiest to be pulled away. Okay, and as you pull away the Cl-, it will leave a positive charge on the carbon from where it was attached earlier. So a carbocationic character will come. So you should understand, after you have taken away the Cl-, a carbocation will be formed. Now my question is, which Cl is going to get removed? Out of 4, you have to choose one. That will be removed easiest by the Ag+. Now I have told you, as you have removed the Cl- from the compound, a carbocation will be formed. So you should understand one thing. Anything happens chemically, or you may see in your nature also, in doing which the outcome is stable. You should understand. For an example, you have plugged Cl number A, Cl number 2, Cl number B, C, D. You make all the 4 different carbocations. You remove A, you will get one carbocation. You remove B, you will get the next carbocation. Similarly C and D, you will get 4 different carbocations, and you have to remove only one Cl at a time. Out of those 4 carbocations, you have to see which carbocation is the best carbocation in terms of its stability. Because if you are making a stable carbocation, the outcome is good, it is stable, it will happen with ease, and Ag+ will find easier to remove that Cl- because the carbocation which is going to form is stable one. So one by one you have to remove A, B, C and D Cl-, will make the carbocation, will check the stability of the carbocation, and you should make a hierarchy. The one which comes the first, the best carbocation in terms of stability, that Cl minus is going to be plugged by Ag plus out of the 4 opportunities. Okay, so let us try to remove one by one. Let us make the carbocation and assess the stability of carbocation. So first of all, I am going to remove the chlorine number A. So as you can see from your question, this is the Cl I am going to remove, and I have removed this Cl as Cl minus. As I have already told, once this Cl, you should understand, once this Cl goes away, it goes as Cl minus and it takes up both the electron and it gets removed as Cl minus and it ties up with Ag plus to make a stable compound AgCl. Now what happens with this carbon? This carbon will be left with the positive charge, and that is the carbocation. That is what I am speaking about, to make that carbocation. So you can see I have made this carbocation after removing the Cl from the number A, Cl number A. Now we have to see whether this carbocation is stable or less stable or more stable, whatever. Let us try to assess its stability. As you see this carbocation, it has got a positive charge, and I have told you, student, a positive charge is like a burden. So the plus charge is on the carbon and it's a burden and it is making the things unstable. So if you disperse this plus charge, if you spread this plus charge, and the spreading of plus charge, I have told you, one of the best means is resonance. So if you can spread this plus charge through resonance, and more you spread on more number of carbon atoms, easier it will be felt by this carbocation. The stabler this carbocation will feel, because if you distribute the burden, the stability increases. The same thing is going to be the platform, and let us try to make the resonating structure. So for that you have to see the presence of conjugation. So I have seen the conjugation. How? Let us see. Plus, single, double. So I will go this way also, that way also. First I am going lower side. So I have seen plus, single, double. So in this situation what we do? We shift this pi bond one position ahead, and as you shift this carbon is going to lose electron, so it will acquire a positive charge. So you can see it has acquired a positive charge, and this pi bond has moved one position ahead. So you can see the pi bond has shifted one position ahead, and these electron has gone towards this positive charge. So a minus charge will come to that. Earlier it had a plus charge. A minus will come because of electrons approach, and plus minus will become 0. So it will have a 0 formal charge. Is it okay? So you have made one of the resonating structures. So I mean, what does it mean? It means that the plus charge is delocalizing, and it's good for the health of the carbocation, because you have to spread the positive charge as possible, as far as possible, because it's going to make it more stable. Now if you try to see another perspective, another way to spread the positive charge, the another way is, you see this plus charge, plus, single, double. So you can spread in this way also. So if I do that, the things will be like this. Then this pi bond is going to shift like this, and you then can draw this below structure. So you can see this pi bond has gone one position ahead. Okay, this carbon will get then a minus charge, and minus and plus becomes 0 formal charge. And as it has moved away from this carbon, so this carbon is going to get a plus charge, and you can see it has got a plus charge. Now what next? As the plus charge comes on this particular carbon, you see two more possibilities of resonance. How? You can see like this, plus, single, double. Similarly, you can see plus, single, double. So it's a cross conjugation situation. The plus can go this way also and that way also. Okay. So if I do that, if I do from the top side, you understand the pi bond shifts like this, and as it shifts like this, you make this structure. This carbon is going to lose electrons, so you understand a plus will come. This pi bond shifts one position, so you can see pi has shifted this way, and this carbon is going to get the electrons, minus will come, plus minus becomes 0. So this is the structure you have got, and the same resonance and the similar type of resonance you can do from below also. In that sense, what you can do, let me clear the screen. Now what you can do, plus, single, double. So you can shift this double bond this way, and as you have shifted, this carbon is going to get the plus charge now. This pi bond will shift one position ahead, it has shifted. Again this carbon is going to get the minus charge, and plus minus becomes 0. So altogether what you have seen is there are 5 structures possible. So I have drawn all the 5 structures, and what does it reveal? It reveals that the plus charge is not localized. The moment you have created this carbocation, the plus was spread, and spreading or delocalization of charge brings stability to the system. So this carbocation is fair enough stable, okay, but we have to make a comparison because we have just taken the Cl number A out. Now we will take B out, C, then D, then we'll compare all the 4 carbocations, and then we'll decide which is going to be the best carbocation. Okay, so this was the case A, 5 resonating structures. Okay, now I will take the carbocation. I will now look on the Cl number B. So you understand this is Cl number B. This Cl I had to remove because I am removing one by one. Earlier I removed A. Now from the compound I will remove B. As I was trying to remove this Cl, I found a problem. What is the problem? You understand? Can you see that this Cl number B has a lone pair? It has 3 lone pair, out of which any lone pair you take and you find that it is in conjugation with a pi bond. How? You see, lone pair, single, double. Can you see that? Yes. And this is a situation of resonance, and because of that situation, it will do the resonance. How? It will do like this. This lone pair can flow like this to make a new pi bond, and this pi bond will shift on this carbon and then sit on this carbon as a lone pair, and a minus charge will come. So you can see Cl will now have just 2 lone pairs because one has gone to make a pi bond, a new pi bond, which you can see it has already made. And Cl will acquire a plus charge because the one from where the electron goes away gets the plus charge, and these 2 pi electrons, you understand, now going to be seen as a lone pair sitting on this carbon, and on which the electron comes, it brings a negative formal charge. So minus formal charge you can see. So why I have drawn this structure? I have drawn this structure to make you realize an important feature. You understand, because of this resonance, a double bond character comes. Because of this conjugation of the lone pair of Cl with the pi system, lone pair, single, double, a double bond character comes. You understand, double bond. And what is the work of double bond? For an example, if you tie 2 balls with a single rope and you try to break that rope away to get the 2 balls. Now you tie the 2 balls, the same 2 balls with 2 ropes, 2 threads. Now the bonding will be more stronger. It will be stronger than the previous case. Now it will be much difficult for you to break them apart, get them apart. So in the similar manner, this conjugation has increased the strength with which this Cl is attached with this carbon. Now this carbon is holding the Cl with more power, with more force, and because of which the removal of this Cl becomes very difficult. It's not an easy thing to remove that Cl because of the double bond character. The bonding becomes stronger, the strength is now more, and it becomes very difficult for Ag+ to pull that Cl away. This is the one reason why B is finding reluctant by the Ag+ to get plugged away. Now, for an example, if anyhow you had removed that Cl minus, if you have removed that, then a plus charge will come, although it is very difficult to remove that. After this plus charge has come on this carbon, you realize this is a vinyl cation, this is a vinyl cation, and you will find it unstable. This is unstable. You know why? Because the plus charge which has been developed on this carbon is not in conjugation. Earlier you saw the plus charge could move from one place to another through resonance, and it was a good thing. The dispersal of charge, the spreading of charge, that was a good thing. But here the plus charge is not in conjugation. Let us try to sing the song of conjugation. You understand? Plus, double, single. Now this is not the situation. The situation of conjugation is plus, single, double. But here you understand it is plus, double, single. This is not the condition of resonance. If it was plus, single, double, okay, it was done. But here it's not done. So the plus charge will remain localized. The burden will remain on a single carbon. It will feel helpless because it cannot distribute the burden. So its stability will be under a scanner. It will be very less stable. Okay. So the B is out of the competition because of these difficulties. First, the Cl is not coming out because of the double bond character. If you remove it also, anyhow, the plus charge is remaining localized, is not getting delocalized. No resonance is possible. So after taking into consideration all these things is very difficult. Now coming on the problem number C, the chlorine number C. Once you had the chlorine, you understand, earlier you had the chlorine this position. I have removed it as Cl minus. This was chlorine number C, and as you have removed, a carbocation has been formed. Once this carbocation is formed, now you have to assess it. I have not drawn the resonating structures, although there is a possibility of resonance. Why I have not drawn any resonating structures? Because I want to make you understand, I want to bring your attention to a very important point. You understand this is a cyclic structure. You can see a cycle, and you will see all the atoms are sp2 hybridized, it is flat also. Now you will find that there is a cyclic conjugation also. Let us see the cyclic conjugation. Plus, single, double, single, double. And in this course, all the carbon atoms have been included. You can understand plus, single, double, single, double. All the 5 carbon atoms which belong to that ring are included. So there is a cyclic conjugation. So cyclic conjugation is there. Now comes how many electrons are involved in this cyclic movement of electrons, cyclic conjugation. Then you will be very surprised that here are 2 plus 2, that is 4 pi electrons. That is 4 pi electrons. And this figure is very alarming. Why this figure is alarming? You should understand. We have already seen once the number of electrons involved in the cyclic conjugation follows 4n plus 2 rule, where n can be 0, 1, 2 and so on. So it will give you, so you put n is equal to 0, so it will come 2. You put n is equal to 1, it will come 6. You put n is equal to 2, it will come 10. If these are the figure 2, 6, 10, then what 14, then what happens? The aromaticity arrives. the species becomes aromaticity, and aromaticity is something which makes you more stable, much stabler than others. So aromaticity is because of 4n plus 2. Here you can understand 4 pi electrons is none of these figure 2, 6, 10. Basically it's anti-aromatic compound, and this was for aromaticity. Student, the condition matches for aromaticity and for anti-aromaticity. Aromatic compounds are very stable, anti-aromatic that much very unstable. So for anti-aromaticity you have very similar situation except one. And what is that? For anti-aromaticity you need cycle, you need cyclic conjugation, flat, all these properties are there. And next is you should have 4n pi electrons in cyclic conjugation, where n can be 1, not 0. 1, 2, 3 and so on. So if you find these figures, after putting the values, it will come as 4, it will come as 8, it will come as 12, etc. So out of these you have got one figure 4 pi electrons. So this, after this compound, after you have removed the Cl number C, will make a carbocation. It is a cyclic carbocation. There is a cyclic conjugation. But the problem is the number of electrons which are moving in this cycle are not following 4n plus 2 rule, which could have made the things very stable, but it is 4 which is following 4n pi rule, which is making the things highly unstable. It is anti-aromatic in character. So that is why removing this Cl as Cl minus is very unpleasant, because it does not bring aromaticity, rather it brings very unstable thing, anti-aromaticity. So please don't go for that carbocation. So after C, now let us try to find what about D. Now you understand, students, this carbon, this point, this carbon had the Cl number D. Okay, once you remove that Cl as Cl minus, it will acquire a positive charge. Now let us try to see what about this plus charge. Is it in conjugation? And if at all it is in conjugation, let us try to make the resonating structures and see what is the possibility. Once you see this plus charge, and if you try to make some resonating structure, plus single double, plus single double. So from above also, from below also, there is a cross conjugation situation. So if I do it from this side below, if I take this pi bond one position ahead, so this carbon will get the positive charge, and you can see the structure. This has got a positive charge. This pi bond will move one position ahead, it has moved, and this carbon will get the minus formal charge. It had plus, plus minus becomes 0. So you have made this structure. Now you have made this structure. After this, you again see a possibility, plus single double, plus single double. So you can bring this pi bond here one position ahead, and as it comes, it brings plus charge on this carbon. So you can see this carbon, the middle carbon has got a plus charge, and this pi bond has shifted into the ring, and it gives you something very pleasant that you can see on your screen, that benzene has came. Benzene, you understand, has got aromatic character. And in the making of resonating structures, if you find benzene rings coming in the course of making the resonating structures, it gives you high benefit. The stability increases a lot because of the aromatic character. So just by shuffling the electrons a position or two, you have seen that an aromatic benzene ring has came, and it gives the stability. Now what will happen in the question, as let us revisit the question, student. In the question what I have asked, first of all you had to tell which out of 4 Cl atom is going to get removed, and then after removing you will get a carbocation. You have to draw the stablest structure of that carbocation. Now, once we were doing the removal of the D number chlorine, we found that there is something unusual which came. Aromatic behavior came. And because of this aromatic behavior, the carbocation will relish this feature much, and it will be very happy because aromaticity has came. So this is seen to be the most stable of all the 4 options we have seen in this problem. And you saw in the case A, you had 5 resonating structures. Here you are looking at 5 resonating structures, and more are possible. And apart from that, these are not simple. A few structures are quite stable, much stabler. How? Because of the aromatic character. And this aromatic character you did not get in the removal of chlorine number A, which you have got in removal of chlorine number D. So now you don't have to leave the carbocation at this stage, because as my question said, you have to make the best possible structure of that carbocation. After the plus charge has came here, you see other possibilities. What is that possibility? Plus, single, double. So you can get this pi electrons into the ring, and if I do that, it looks like this. If you pull it like this, you understand, this gets a double bond character, and this carbon loses the electron and a positive charge comes. And now again this plus charge is in conjugation, plus, single, double. So again you can bring this double bond here and you get the plus charge from where the electrons are going away, this particular carbon, and a plus charge comes here. And in all these 3 structures, the last 3 I have drawn, you can see the benzene ring is coming, which is making the structures quite stable because of the aromatic character. Okay, why I have taken the plus charge from middle of the situation, middle of this compound, to finally to this carbon, because of very important reason. Now after I have made this carbocation, I will not stop at this point, because there is something more to this carbocation which is still left, and that thing is I have given here. You see, you had got the plus charge over this carbon. Okay, now to this carbon which had the plus charge, Cl is directly attached, and I have told you, if there is a carbocation from which an atom is directly attached, having lone pair, then there is a possibility of resonance. And the same thing is happening with this carbon. This Cl has got 3 lone pairs. As you can see, there are 3 lone pairs, and it can give one of the lone pair for the resonance, for the sake of resonance, conjugation. And let us try to give it. You should give it like this. The lone pair will float 1 position ahead. It will make a new pi bond, as you can see on the screen. And out of 3 lone pair, it has lost 1. Just 2 lone pairs are going to be seen now. And as the electron goes away from Cl, a plus formal charge will come, and simultaneously a minus charge will come to the carbon where the electrons are coming towards, and that will get a minus, and plus minus becomes 0. So you find that this final structure is something glorious. What is the glory in the last structure? The glory in the last structure is, this is a structure, student, where you have 2 great features. One is it has aromatic ring, and that aromatic ring you can see as benzene. This is the aromatic ring. The second very important thing is, all atoms are octet completed. Now this is an amazing thing which you have not got till this point, but this structure. This is the only structure which has aromaticity also, and all the atoms will have completed octet. If you count for Cl for an example, 2 to 4 and 2 bond, to 6 to 8. Okay, For carbon also now it is making 4 bonds. All you can try, all atoms will have 8 electrons. Hydrogen will have 2 electrons. Okay. Now this is the one we were looking for. The best Cl to be removed by Ag plus is the Cl number D. Why it got removed? Because after removing that Cl, the carbocation which got formed acquired aromatic character. And to make the best possible structure of that carbocation, we have arrived to this final structure where we got all the atoms having octet completed. So the answer is the Cl number D is going to get removed with utmost ease and easily to give you the best possible carbocation and structures in front of you. I hope you may have understood all these fundamentals, and I try to dissect the things to a very fundamental level. I'm ensure that I keep on repeating the things. Why I do so? Because I think that you may forget what you are told in the previous classes. So I keep on repeating all those details, and it's a wonderful thing. Once you keep on reviving your old concepts, okay, and like these I will be bringing the problem, more and more problems for you. I hope you all must be enjoying all these problems and will do a lot in future also. Okay, till then, take a good care of yourself. Thank you very much.